Good morning, students. This is Latif sir. In this video, I am starting the chapter 7 of class 10th chemistry. The topic is metallurgy. In this chapter, I will discuss how to extract metal from its ore and minerals. You know, in nature, there are many types of metals are found. Some of these metals exist in free state, like gold, platinum. These are less reactive metal. Okay, and they are found in nature in free state. And most of the metals are reactive. So they occur in nature in combined state in the form of their oxide or in the form of their carbonates, halide, sulfide. Okay, and it is easy to extract less reactive metals like gold, platinum, because they found in nature in free state, and it is not easy to extract reactive metals like aluminium, like iron. Okay, so in this chapter I will discuss how to extract metal from its from their compounds, and these metal compounds which are found in nature are known as minerals and ores. Okay, so first you have to know what are mineral and ores. Minerals and ores. Okay, so minerals are chemically occurring compounds of metals which are generally mixed with other substances such as soil, mud, sand, silica, limestone, rock. And these other substances, that is these impurities like soil, mud, sand, silica, limestone, these impurities are known as gangue or matrix. Okay. So in minerals main metals is present along with some impurities. And ores, what are ores? Ores are those minerals from which metals are extracted commercially at comparatively lower cost with minimum effort. Okay, so ores are those minerals from which you can extract metal. You can extract metal easily at a lower cost. That is why you can tell all ores are all minerals are not ore, but all ores are mineral. Okay. According to the syllabus, you have to remember the main ores of aluminium, zinc, and iron. All this is given here. Ores of aluminium. Main ores of aluminium are bauxite, cryolite, feldspar, mica. Their formula also given here. You can see bauxite is Al2O3.2H2O. Cryolite is Na3LF6. Okay. Similarly, main ores of zinc are zinc blende, that is ZnS, and calamine, that is ZnCO3. Main ore of iron is are red hematite, that is Fe2O3, and brown hematite 2Fe2O3.3H2O. Okay, according to the syllabus, you have to remember the main ores of aluminium, zinc, and iron. Okay, here in this table it is also given main ores of aluminium, iron, and zinc. Okay, so according to the syllabus, reduced syllabus, you have to read main ores of aluminium, zinc, and iron, and extraction of aluminium, and the steps how to extract metal from its ores. Different steps are not given in the syllabus. Okay, so now I'll discuss how to extract aluminium from its ore, bauxite. You know, the main ore of aluminium is bauxite. So extraction of aluminium from bauxite. Extraction of aluminium. In aluminium, in bauxite is the main ore of aluminium. You know that. In bauxite, 60% is Al2O3, that is alumina, and the rest being sand, ferric oxide, titanium oxide, that is impurities. Sand, ferric hydroxide, titanium oxide, these are impurities present in bauxite ore. So first you have to remove this impurities, sand, ferric oxide, titanium oxide, from bauxite ore to convert bauxite, that is Al2O3.2H2O, into Al2O3, pure alumina. Okay, and this is known as concentration of ore. Concentration means purification of ore, that is removal of impurities present in ore is known as concentration. So concentration of bauxite ore or conversion of bauxite into pure alumina, and this process is known as Bayer's process. Okay, using Bayer's process you can remove the impurities present in bauxite ore. In Bayer's process, first you have to heat the grinded or finely divided bauxite ore, and you have to heat the grinded finely, and first bauxite is grinded finely and it is heated to remove volatile impurities, and then it is heated under pressure with concentrated caustic soda, that is NaOH solution. This is the first step of Bayer's process. You have to heat the bauxite ore with concentrated caustic soda, that is NaOH solution, and the bauxite ore will be converted into sodium metaaluminate, NaAlO2. The chemical reaction is Al2O3.2H2O plus NaOH. 2NaOH implies 2NaAlO2, sodium metaaluminate, which is soluble in caustic soda, plus 3H2. So in Bayer's process, first you have to heat the bauxite ore with caustic soda solution for 2 to 8 hours at 140 to 150 degrees Celsius. The bauxite dissolves and forms sodium metaaluminate and leaving behind the impurities, and these impurities are called red mud. And in red mud, ferric oxide, sand, these impurities are present, which are removed by filtration. This is the first step of Bayer's process. Okay, in second step, after filtration, you have to dilute the sodium metaaluminate solution with water, and you have to cool the solution to 50 degrees Celsius, and you will get a precipitate of aluminium hydroxide, that is sodium metaaluminate. After diluting and after cooling, it will be converted into precipitate of aluminium hydroxide, AlOH whole thrice. The reaction is NaAlO2 plus water arrow NaOH plus aluminium hydroxide, and the other soluble impurities remain dissolved in sodium hydroxide solution. Okay. So in second step, you will get, in first step, bauxite is converted into sodium metaaluminate, which is soluble in sodium hydroxide. In second step, you have to take the filtrate, and you have to cool the filtrate to 50 degrees Celsius, and after diluting you will get a precipitate of aluminium hydroxide, and in last step you have to heat the precipitate to convert the aluminium hydroxide precipitate into pure alumina, Al2O3. So the chemical reaction is 2AlOH whole thrice. 2AlOH whole thrice implies 1000 degrees Celsius, Al2O3 pure alumina plus 3H2. So using this entire process, you can convert bauxite ore into pure alumina, and this process is known as concentration of bauxite ore or purification of bauxite ore, and the name of the process is Bayer's process. So after getting pure alumina, Al2O3, you have to reduce Al2O3. To get aluminium metal, and this method of reduction is known as electrolytic reduction of alumina. Electrolytic reduction, main step of extraction of aluminium from alumina. Electrolytic reduction. using the concept of electrolysis, and the name of the method is Hall-Herold's process. This is known as Hall-Herold's process. Extraction of aluminium from alumina using electrolytic method, that is Hall-Herold process. This is this is actually electrolysis. In this process you have to take electrolytic cell. The electrolytic cell is rectangular iron tank with sloping bottom. The sloping bottom of the tank facilitates the removal of molten aluminium, and the tank is lined with gas carbon. And electrolyte used in this process, the electrolyte is a mixture of molten alumina 20%, cryolite 60%, and fluorspar 20%. So electrolyte is the mixture of in Hall-Herold process during extraction of aluminium from alumina, that is electrolytic reduction. Electrolyte is used, it is the mixture of 20% alumina, 60% cryolite, and 20% fluorspar. And powdered coke is sprinkled over the surface of the electrolyte, and temperature required, the molten electrolyte is kept at 950 degrees Celsius. And now see the reaction during electrolysis, during electrolytic reduction of alumina. Okay, in this process, in electrolytic cell, the carbon lining is act as cathode, carbon lining, and the graphite act as anode. And you have to take the electrolyte, mixture of electrolyte within the electrolytic cell. Molten mixture of molten electrolyte you have to take within the electrolytic cell, and in this electrolytic cell, carbon or graphite act as anode and carbon lining act as cathode. Now see the cell reaction. First, dissociation of electrolyte. Cryolite will dissociate to give Na plus, Al3 plus, and F minus. Fluorspar will dissociate to give Ca2 plus and F minus. Alumina will dissociate to give Al3 plus and O2 minus. Alumina, Al2O3. The cathode reaction is Al3 plus ion will migrate towards cathode and will accept electron from cathode and will be reduced to and will be converted into pure aluminium metal at cathode. So during electrolytic reduction of alumina, you will get aluminium metal at cathode. The cathode reaction is 4Al3 plus 12 electron implies 4 aluminium. Now see anode reaction. Anode reaction, the oxide ion will migrate toward anode and will release some electron, and it will be converted into oxygen gas. Okay, those anode reaction is 6O2 minus 12 electron implies 6 oxygen atom, and now see 3 plus 3 oxygen atom plus 3 oxygen atom will be converted into 3 oxygen gas, oxygen molecule. Okay, so main thing that during electrolytic reduction of alumina, you will get pure aluminium metal at cathode and you will get oxygen gas at anode. And the anode which is made up of graphite or carbon. The anode is oxidized, the carbon of anode is oxidized to carbon monoxide, which further form carbon dioxide. Okay, the anode reaction. Anode reaction is at anode mainly you will get oxygen, and this oxygen will react with anode, and the anode will be converted into the anode, that is carbon or graphite will react with oxygen produced at anode, and it will be converted into carbon monoxide and carbon dioxide. Thus the anode has got to be replaced from time to time as it get oxidized by the oxygen evolved at anode. Now see, role of cryolite in extraction of aluminium. Role of cryolite. Cryolite lowers the fusion temperature. Cryolite lowers the fusion temperature of alumina from 2050 to 950 degrees Celsius, and it enhances the conductivity of the mixture. It is the role of cryolite. Role of fluorspar and cryolite. Role of fluorspar and cryolite in extraction of aluminium. This mixture act as a solvent for the electrolytic mixture and increases its conductivity, since pure alumina is almost non-conductor of electricity. Okay, these roles you have to remember, very important question. And now see the role of powder coke. It is a powder coke is sprinkled over the surface of electrolyte mixture because it reduces the heat loss by radiation, and it prevents the burning of anode. Powder coke, role of powder coke, it reduces heat loss by radiation and it prevents the burning of anode. Okay, so after electrolytic reduction, that is using Hall-Héroult process, you will get pure aluminium from alumina at cathode. Okay, the entire process you have to remember, which cathode, which anode is used, what is the electrolytic mixture, what is the role of cryolite, what is the role of fluorspar, what is the role of coke, powder coke in this electrolytic reduction of alumina. Okay, and refining of aluminium is not given in the syllabus. Okay, it is not required, refining of aluminium. And next topic is alloy. What is alloy? Okay, so you know very well what is alloy. It is a mixture of two or more metals, or one metal, one non-metal. Okay, so alloy is a mixture of, an alloy is a homogeneous mixture of two or more metals. Alloy is given in the syllabus. Example of different alloy you have to remember. Okay, so an alloy is a homogeneous mixture of two or more metals, or of one or more metals with certain non-metallic elements. The properties of alloy are often greatly different from those of the components. Gold is too soft to be used without a small percentage of copper, and the corrosion and oxidation resistance of steel is markedly increased by incorporation of 15 to 18% of chromium. Okay, that is it. The properties of alloy are often greatly different from those of its components. Now see here, one point is given: an alloy melting in the range of about 51 to 260 degrees Celsius usually contain bismuth, lead and tin, etc. These alloy are called fusible alloy. Fusible alloy melting temperature is from 51 to 260 degrees Celsius. An alloy melting in the range of about 51 to 260 degrees Celsius usually contain bismuth, lead, tin. These alloy are called fusible alloy. Amalgam. In amalgam, one component is always mercury. So amalgam, a mixture or an alloy of mercury with number of metals or alloys such as sodium, zinc, gold, silver, as well as with some non-metals, is known as amalgam. So in amalgam, it is a mixture of mercury with some other metal. Zinc amalgam means zinc plus mercury. Sodium amalgam means sodium plus mercury. Okay. Dental amalgam. It is a mixture of mercury and silver. It is a mixture of mercury and a silver tin alloy. Dental amalgam. And mercury does not form an amalgam with iron, and hence mercury is commonly stored in iron bottles. Now see purpose of making alloy. There are many purposes to enhance the hardness of metal, to increase the brightness, to increase the beauty of metal. So these are purpose of making alloy. So strength of iron is increased by making steel. Steel is an alloy of iron. Brass is stronger than its component copper and zinc. Hardness increases. Okay. After making alloy, aluminium bronze looks like gold. That is beauty of metal increases after making alloy. Nichrome, which is a mixed alloy of nickel, iron, and chromium, is more resistant to electricity. Huh. Resistance to electricity. Iron is an alloy of nickel, iron, and chromium. Okay. And bell metal. See bell metal. What is bell metal? It is a alloy of copper and tin. 78% copper and 22% tin. Is more sonorous than copper or tin. Solder. Solder, it is an alloy of lead and tin. Okay, and solder, it is an alloy of lead and tin. Tin lowers melting point of alloy and it melts at 180 degrees Celsius, and it is useful for making electrical connections because its melting point is lower than the individual melting point of both of the component. Type metal, it is alloy of lead and tin. Lead is 75% and tin is 10%, and antimony is 50%. So type metal has a low melting point, and sodium amalgam means sodium plus mercury. Okay. Now see reasons for alloying. Reasons for alloying. Depending upon the purpose for which the particular alloy is used, the reasons are different. First one is to modify appearance and color, to modify chemical activity, to modify casting ability, to lower the melting point, to increase the hardness, to increase the resistance to electricity. So these are some reasons for alloying. Method of alloying is not frequent. Okay. Now see alloyed as solid solution. Alloys, all alloys are solid solution mainly. And mercury is the liquid metal, you know that. Okay. Here in this table, alloy of different metals are given, like alloy of aluminium, that is duralumin and magnesium, and their percentage composition also given. In duralumin, aluminium is 95%, copper is 4%, magnesium is 0.5%, manganese is 5% is given, and properties and use all are given. Properties of duralumin: light but as strong as steel, hard and resistance to corrosion, highly ductile. These are properties of duralumin. And it is use of duralumin, it is used in to make bodies of aircraft and buses, tubed buses, and light tools, pressure cooker. Using duramins you can make these substances. Okay. And magnesium, it is in magnesium 90 to 90% 5% aluminium and 10 to 5% magnesium. And its property resistance to corrosion, it is strong. It is used to make aircraft, scientific instrument. Okay. Metal mirror. So these are some use of magnesium. And ore of alloy of iron, stainless steel, it contains iron, chromium, nickel and carbon. Iron, chromium and nickel and carbon. Stainless steel, it is properties of stainless steel: resist corrosion, lustrous, hard, resistance to acid and alkalis. It is used to make utensils. Okay. Ornamental pieces, surgical instrument. So all these composition, name of alloy, their composition and their properties and use. All this you have to remember. Okay, alloy of zinc and copper, brass, bronze, German silver. In German silver there is no silver metal, remember that. In German silver, copper, zinc and nickel present only, there is no silver. Okay, and lead, the alloy of lead, solder or fuse metal, it contains 50% lead and 50% tin. Okay, and it is used in welding. Brass and bronze, brass is copper and zinc, and bronze is copper and tin and zinc. In brass mainly copper and zinc is present, and in bronze main component of bronze copper and tin. Okay, and 2% zinc also present in bronze. And properties of brass and bronze all are given here, you can see. Okay, so all these properties, use, composition of alloy, different alloy, you have to remember. Thank you students, and this chapter is completed.